In this video, I will discuss the new enhancements included in the new ETABS 20.0 release. Here are all the items included in the new version of ETABS. A few new items have been included for loading. Included pattern loading, which can now be assigned to slabs. We'll go through an example of this. Auto wind loading has been added for the new Australian New Zealand code, as well as temperature gradient loads, which can now be assigned to frames and shells. For design, enhancements to the Eurocode 2 2004 concrete frame design, some updated reporting elements for PT slab design have been included. Also updates to the Indian code 456-2000, providing options to increase longitudinal reinforcement in slabs, as well as enhancements to the steel frame design for Eurocode, NTC 2008, including improved calculation of MCR and results output as well. For analysis, new stage construction operations are available to change stiffness modifiers that are applied to frames and shells. Updates to the API have been added, enhanced for different codes as shown on the screen. Data exchange, so this is new. EXR files can now be imported and exported directly between ETABS and SAP 2000 and SAFE. Beforehand, you needed to use the CSI Cross Revit tool, which is not the case anymore. For graphics, we've added some PT tendon display options, which we'll go through. There's been some updates to our performance-based design, including nonlinear frame hinges can be automatically generated, coupling beams per ASCE codes. Users have specified rebar material now available. Hysteresis type can now be specified for certain types of frame hinges, as well as updates to the import from Perform 3D, now supporting different components as well. We'll go through a full modeling example, introducing support lines for faster modeling of design strips, tendons, and slab panels. We'll generate these slab panels and we'll go through an analysis showing you how all the live load has been applied to the structure, as well as some time-dependent behavior for concrete, different codes, and moment and shear releases can now be specified along lines within a slab object. So a lot of things have been added to the latest version of ETABS, so let's get started. In this example, I'll be talking about support lines, slab panels, the definition of auto pattern live loading, and we'll show you how to assign tendons automatically to these design strips. Okay, so first thing I'm going to do is go ahead and put in some columns in the structure. Concrete columns, and we'll just do an auto generation of these columns using the rubber band draw tool, and then you can put them in all these specific locations. So once we have these columns in, now we can generate our support lines. Okay, so what are support lines? They're used as the basis for the creation of objects that are used for slab design, such as design strips and slab panels. So for areas where the design strips can't be easily defined on grid systems, it can be useful to manually draw support lines of your own. So we'll show you how to generate them automatically, and I'll manually draw a couple as well. So to access the support lines, we'll simply go to the Edit menu, Add Edit Support Lines. We're working on Story 1, and we have a couple grid systems that have been defined. G1 is in this bottom left-hand corner, and we'll simply click Apply. We'll put this in the A layer. And you can see the support lines are being automatically generated. I'll just take a moment to populate the support lines throughout the model. Okay, so now I automatically generated these support lines for the rectilinear coordinate systems, and I'm going to choose to draw the support lines manually for the cylindrical system. So I can just click from point to point here. Just quickly add in a column. And you can see I'm clicking from one column to another to generate these support lines. This just takes a moment to generate the support lines along the cylindrical system, clicking from column to column. Okay, there we go. Once we have all the support lines drawn, now we can generate the slab panels. Okay, so what are slab panels? Slab panels are non-structural geometric objects defining an area of the slab. So they would be normally bounded by support lines. They're currently used in the program for multiple purposes. The one we'll be talking about here today is for the purpose of automated pattern loading. So let's generate these slab panels by first I'm going to select these support lines which I just defined. So under select object type, support lines in a couple different layers. And you can see in the bottom left hand corner of the screen 25 support lines have been selected. Now if I go to edit, add edit slab panels, I have a couple different options. I could have added them using the grid system, or the second option is using selected support lines, which is what I've done here. Okay, so now all the slab panels, it recognizes the locations of the support lines and have generated the slab panels automatically. So now we're ready to define the auto pattern live loads. So under define, load patterns, you'll need to select under type, pattern live auto. And we can give this a specific name. And we'll click OK. So now that we've defined our load pattern, the program will automatically create a multi-step linear static load case with this load pattern. So each step will load a slab panel with the sum of all the loads applied to it with a load pattern type of live or reducible live. So let's take a look. So if we go to define a load cases, you can see here automatically this live load case has been defined, and making sure it's multi-step static. You can take a look here and click modify show. And just to make sure that we're about to apply some loads to the shells under this live A load pattern name. So now that the load patterns and load cases have been defined, we need to go ahead and apply loads to the shells themselves. So actually, I don't think I put shells in this model. Let's go ahead and add those. I'm going to turn off these slab panels for a moment. And if I click on the quick draw floors, we can simply click on each one of these bays to generate a floor, or using this rubber band draw tool, you can generate areas very quickly. There we go. Now, if we select all these shell objects, we can apply a live load to it. Under the assign, shell loads, uniform, we'll put in a 60 pound per square foot load, and now you can see that have been applied. We can go ahead and turn on the slab panels again, and there we have our structure. So now why don't we go ahead and run the analysis and see how the live load application is applied to the structure. This will just take a moment. Now the analysis has been run, let's take a look at the deformed shape for the auto pattern live load case. So you can see as I step through each one of these load applications, for each one of the slab panels load has been applied automatically to each panel, and I can step through them to see that it has been applied correctly. So that's a neat new feature that's been added into ETABS. Saves the user quite a bit of time instead of having to go through and apply loads manually for each specific portion of the slab. You can simply define and apply these slab panels and have the load automatically applied. So these results are available for each step as well as range combination of all steps. So this range combination gives the maximum and minimum of all possible patterns of loaded slab panels. So these range combinations later can be used for design with any gravity load combination, including applicable load factors from the combination as well as live load reduction factors. Okay, let me show you one other thing that can be included in this model. There's a quick way to add tendon elements to design strips. Why don't we just add a couple tendons into this model? So to do so, if we go to edit, why don't we go ahead and actually select some support lines. So if we go to select object type support lines, Then we can go to Edit, Add Tendons, and you can add tendons using these selected support lines. You can select the different layout type, whether it be distributed or banded, set all the parameters for the specific tendon layout, click Apply, and you can see all the different locations of where these tendons have been applied. So some new features that have been included in the tendon profile, if I simply select the tendon, right-click on it, you can see the tendon vertical profile has been updated. Some new features include showing of tendon control points and nodes, showing the center of gravity, distance from the nearest edge. You can also include the tendon radii of curvature in this plot, and finally balancing upward forces can be shown in this form as well. All these other features are existing, including modifying the tendon layout, showing the tendon point table, and making manual adjustments to the span and other data in this form as well. You can also update tendon load losses and loads as well.